Hi, my name is Rajveer, founder of CORE and Compile. In this video, we're going to see how to bridge IT and OT. I will show you several examples where you will see how I'm acquiring the data from the OT, pre-processing the data, and sending it to the IT world. Now, before coming to conversions of IT and OT or how to bridge IT and OT, first we need to understand why we need to do that. So if we see in our OT world, we have sensor data, machine parameters, alarms and events, and production data. So we have a lot of data going in our shop floor. And we know that we can optimize this manufacturing process using IT. Because IT offers better data analytics, better data storage. It can also help to optimize the parameters which is running on the OT world. And with this data, we can also have better future predictions. And with these future predictions, we can organize our resources. So we can do some resource planning. So there are several benefits of converging your OT with IT. So now the why is cleared. I'm going to show you how you can do that easily and flexibly. For that, I'm using ctrlX Core with an app called as DeviceBridge. So I'm going to use DeviceBridge app installed in ctrlX Core to converge these two worlds. So this app will help you to acquire the data in real time from the devices, and I can pre-process the data using built-in algorithms. So I can write code inside the app to process the data. And finally, I will show you how you can deliver this data to the IT world. So in short, it can do real-time data acquisition, and you can have plug-and-play deployments. And using graphical interface, it will make it really easy to work on this app. So let's see what are this example again. So we have an operation technology here, and this DeviceBridge app can acquire the data from 40 plus controllers like Siemens, Allen Bradley, Beckhoff, Rexroth Bosch Company, Mitsubishi, MODBUS, Delta, MQTT. So there are several protocols and several PLCs which are supported by this app. And once it acquires the data, this app can be used to process the data. So we're going to acquire the data, we're going to transform the data. And to process the data, we can use several functions. We can use basic mathematics, we can use if-else statements, we can route the data, or we can use any data model. And why we need to do that? Because when we are sending the data to the IT world, you have to play around with the data. You can't connect directly your OT with IT. You have to process the data. So this processing you can do inside the app. And finally, you can deliver your data to your IT world, where you can deliver the data to SQL servers, Azure IoT Hub, Kafka, MongoDB, MQTT. So I'm going to show you several examples in which I'm going to acquire the data from Siemens PLC and Delta PLC via S7 connections, OPC UA or MODBUS. Then I'm going to show you how you can process the data, and finally, how you can deliver this data to MongoDB running on the cloud and MQTT running also on the cloud. So these are the several examples we're going to see in the next few minutes. So let's begin with our first example. In the first example, we have to collect the data from Delta 12SC PLC via MODBUS TCP IP. So we have our app installed in ctrlX Core. And we have another PLC, Delta 12SE, which has a communication protocol of Modbus TCP IP. And this PLC has three parameters: tank level, fill wall status, drain wall status. And if I want to show you some example, I can show you here. This is my example where I have a tank, and this has a fill wall which is filling the tank. And then it has a drain wall which will drain the tank. And here you can see real-time status of your level meter. So these three parameters are already configured in my Delta PLC, and this is the code which is running inside. It's a very simple code which is just filling the tank and draining the tank. So this is just an example that how you can get the data from your PLC, which is running a process, in this case, for example, tank level control. So we have to read three parameters, which is tank level, fill wall status, and drain wall status. And here I've mentioned the Modbus address of this status. So what you have to do is, first I will show you my ctrlX Core, and this is how, when your app is installed, you have to click on the home button here and your app data will be displayed here. So the app which I'm using again is DeviceBridge, and with this app I'm going to acquire the data. So I'm already logged into my ctrlX Core, the app is installed, and first step you have to do is click on the device. So we have to first add the devices. So with my current license, I can add only 2 devices. So if you have a license to add more devices, you can add even more. So in these examples, I will add maximum of 2 devices. So let's begin with the first device. You can go to plus, and here you can see several devices which are supported by this app. And here I know my device supports Modbus, so I will click on Modbus, and my protocol is MODBUS TCP. Now when I select this protocol, I click on next. I have to enter the name. I can type Delta 12 SE, and the Modbus address of my PLC is basically the IP address is 192.168.0.152. That's the IP address. Port number is by default 502. Everything else is fine. I click on save. So my PLC has been added. And if I want, I can directly test that here. So by clicking on these dots here, you can click on test. And if your communication is working fine, click on this play button. You will see a feedback device test was successful. Everything looks great. Next is we have to add tags inside this so that we can read the data. So I go inside this device, and then I can click on plus icon again. And here I can select my tag type. So my tag type is MODBUS TCP variable. Click on this variable and click on next. And the tag name, I can say it's tank level, and it's my holding register, and the address which I've already mentioned in my slide, 4096. 409, I think it's 7. Let me check that again. 4097 is my address for the tank level. Unit is 16 bits, and count 1 is fine. I click on save, and I have my tank level address defined here. Similarly, I can do another one. I will do MODBUS TCP variable. In this case, I have my fill valve. Also holding register, the address is 4100, and I save it. And then I have another one very quickly for my drain valve, 4004101, and click save. So I have my 3 tags defined here. And what I can also do is I can also monitor this tag to make sure the data is coming. So if you go here monitor, you can select the tags and then you can monitor it here. And here you can see that the data is coming. This is my tank level. This is showing in percentage. So if you see here, this is showing in percentage. This is percentage. Now you can see 83, 84, and you can see that here as well. Parallelly, you can see the status of drain valve and fill valve. This is actually amplified by 100. So if it's 2, it's 200 here. And if it's 10, it's 1000 here. Don't worry, we will pre-process this data as well. So you can see that the status is coming for the tank level, fill valve, and drain valve. This was the objective of the first part, collect the data from Delta 12 SE PLC. And you can see that how easy it is. Within few seconds, we are reading the data in our app. All right, let's move ahead. Another thing is it says use a business model blockly to show the status of the tank and generate an alert. All right, so at the moment we just added a device and we can see the tag status here. Now we will use a collector. Now collector is being used to collect the data from the devices. So suppose if you want just 2 tags from the device, or if you need all the tags, or if you just need 1 tag, you can define that in a collector. So in the collector, I will go to click on add, and here I will go for generic collector and JSON collector. I will use a JSON collector, and this will automatically define my data into a JSON format. Very interesting. Let's click on next, and here I will put name as example1, collector description. Okay, let it be like this. Now this is the interval, which shows you after how many interval the data is being pulled from the device. So here it's 1 second by default, which is okay. And the script type, here you define how do you want to process your data. There are 2 ways. One is using blockly, another is using CSharp script. So in the first example, I will use blockly. So everything is fine. So example 1 is here. Now in the write back defines if you want to write back the data to the device or not. So in this example, we don't do that, but I will show you next example how you can also write the data back to a PLC. And comes the business rule. Before coming to business rule, I would like to show you my endpoints. So in endpoints, you can click on this tag here. Now this collector has to collect the data from the PLC. So if you click here, you can see here your PLC is already defined here, and you can just select which tags you want to see. So my task says use the business model to show the status of the tank and generate an alert when the level is above 70%. Okay, so let's say I take all the tags and I click OK. Now go back to my business rule, and here I have to remember the variable, which is iTank level. Now in this business rule, I have to define an alert when the level is above 70%. So in this case, I will go to my logic and I will take a condition. So I have a condition of if, else, and do. Okay, let's take this condition out. And here, if you select on this icon, you can also define if you want to use else if or else. So let's say I use else condition as well. So now I have if, do, and else. Now what should happen if the level is above 70? So I can take a condition. Before taking a condition, you can also see all the tags you want to read are coming in the collector. So here you can use this read. So I have read iTank level as integer because I'm reading an integer. So now I need a condition. So I'll take this condition here, or I will compare. So this means this I can compare if the tank level is greater than 70%. So this condition you can put inside this and you can bring it here. Super easy, just using the blocks. Now here we need 70. So this you can find, I hope, in assign. You take the assign and put the number here, 70. So if it's greater than 70, we need an alert. So what you need to do, you need to print a print statement. So you can do assign and you can bring it here and you can go to log and you can do print. So I want to print, but I want to print, I can put here tank level is high. Otherwise I can print, I can just copy paste tank level is okay. Very easy. Now let's see what will happen if I execute that. You can click on save. Now in the collector itself, you can test your collector without publishing the whole program. I can do that by pressing on this button play. And here you can see tag monitoring. You can monitor your tags. And if you go to your message, you have a message here saying tank level is okay. And you can see that tank level is coming here, 62, 64. And when it's going above 70, you will see tank level is high. And you can see that the format is JSON because it's a JSON collector. It is collecting all the parameters in JSON. So you can see that it's tank level, fill valve, drain valve, and timestamps and the ID. So you have 5 parameters coming here in your JSON collector. So this was the objective of the first example, how you can read the value from the Delta 12 SC PLC using Modbus, and how you can use a business model. So you see this business model is totally defined in the app. And using this business model, you can define what are the conditions that you need to play with this parameter. You can have if-else conditions, you can have a logical conditions, you can compare the values, you can do loops, you can do mathematical, some string functions, many things you can do. All right. So this was about my first example, part 1. Let's see what do we do next. In the next example, I have to collect the data from S7-1500 PLC using S7 connection and using CSharp code, making a business model. So let's see first how you can add this device. So first we go back to again our devices and we add another device. Here I go to plus again. And now it's my S7 connection. So let me see where we can find that. In Siemens S7, looks great. Click on next. And now I need an IP address. So I will type here S7-1500. I'm using S7-1500 model. You can also see in my trainer. And I'm going to put the IP address 53. That's my IP address. Port address is by default. Perfect. And rack and slot, I have to make sure my slot address is 1. Everything else is okay. Click on save. And then let's see, test this device. I go to test and click on play. Test completed with error. I have to check what is the error. Okay, edit. Maybe the port address is 102. Click on save and let's test that again. Now test is completed. So my Siemens device is configured. Now what I need to do is I need to configure the parameters. So in the Siemens PLC, if I show you, I have a sample logic. If you see on my screen, I have a logic where you have iTank level and alarm. Okay. Now our device is added. What we need to do now, let's see. Collect the data from S7-1500 PLC using business model and C# code. Trigger an alarm in S7-1500 PLC when the tank level is more than 70%. Alright, it's quite similar what we already did, but in the Siemens PLC what we have to do, first we have to read this tag, and based on this variable we have to write back to PLC if this is true or false. So if this is more than 70, we have to write here true. If this is less than 70, we have to write here false. So we have to write the data as well. So I will bring back this here, and let me just reorganize my window. All right. So inside the Siemens PLC, again, I will add some tags. So here I will go to plus, select my tag type. Now here I have to make sure my tag is write enable because I want to write back the values. So I will take two tags with the write enable. Write variable, go to next, and you can put the tag name. I will put iTank level again. And in this case, it's coming from Siemens PLC. I will put cm. It's like centimeter. Why I did that? Because this is linked to my next exercise. So for example, I just keep it like this. The type is it's coming in integer, and click on save. Or before going to save, you have to configure that. Now this tag, if you notice here, it's coming from a database. We are using S7 connections. And in S7 connection, you have to make sure your database is not optimized. You have to make sure this is unchecked because we have to work with the offset when we are reading using S7 connections. So unoptimize your data, and then you have to see where is the data located. So my tank level is located at 0.0. So I have to write the address. This is DB1 because this is read from database DB1. .db comes x0.0. That's how the address is defined for my first tag, which is iTank level integer. All right, click on save. This is done. Now we'll make another tag. This is for the alarm. Also I will do write variable. Click on next, and I will put x alarm, and this is my bit address. This is my Boolean address. Again, configuration db1, and this will be dbx2.0. This we can confirm from here. And this is a Boolean, that's why I took bit address. Count 1, click on save. So now I have two addresses here. If I want to check that, I can quickly go to monitor. And let's say this is showing now 0, alarm is false. Let's change the tank level, let's say 56, and I make it true. So here we can see that the values are coming perfectly fine. So our device is configured successfully within a fraction of a second with Siemens S7-1500 via S7 connection. Now we'll come back to collector. Now I want to collect this data. Okay, collector, the task of collector is to collect the data from devices. And our task was to collect this data and make a business model using C# code such that if the value is above 70%, I have to create an alarm. All right. So let's go back here, and I will create a collector, generic, and because we have to write back the data, I will use as a dynamic collector. Click on next, and here I will type name example 1. Let's say this time it's Siemens. Collector description is by default, interval 1 second is fine, and here script, I'm going to use C# script. And write back function, I have to make sure it's true. You can read the written tag, you can enable write back. Then comes dynamic endpoints, and I will select here my Siemens, two tags, click OK. Tags are defined, click on save. I will come back to business rule. Before writing the business rule, you also have to make sure if you go to your settings, here you have write back settings, this should also be true. This you have to make sure, okay? Let's go back to our collector. Siemens collector, edit. And now we have a business rule. And now you can see that you can write your business rule also in C#. So So you have use Blockly, which is for people who can't code or who are new to programming. And this is for advanced programmer. And I'm going to use a very basic example. So I've already written the code. I don't want to write that again and waste 2 minutes of yours. So I will just copy paste the code and put it here. And then I will explain you the code. The code says we take a variable tank level and we read this variable from our tank. So our dynamic endpoint, which is defined for tank, was itank level CM. So we have to make sure this address is same. So I will write here, we'll just change the address. CM, and this we don't need. So this we also don't need. We want to convert this. So what I will do is I will copy this. Let me delete that. So we are reading the tank level in integer. So this itank level is my endpoint, and this endpoint is defined here. So what do I write? I take a variable tank level is endpoint dot itank level centimeter dot to integer 16. So we read the variable and we make sure this is being read in integer format. Now we take this variable. If this variable is more than 70%, we generate an alarm and we write the value of X alarm as true. Else, we will make the alarm 0. So very simple. You read the variable, store that into tank level, and then you just compare. That's it. This should work. Let's save that. And now we're going to test that. So I will click on this play button again. And you can see that here we have itank level centimeter. It's trying to read. Let's wait a couple of seconds. Now it's reading, it's 56 and it's false. So let's change back the value. I will make it more than 70. Let's make 78. And you can see that the value goes to true. So there's no PLC logic inside. The logic is defined in our bridge app. And using that logic, you can trigger the data in your PLC. This is optional. Sometimes you come across a situation where you have a PLC running in your plant and you can't change the logic. It's not allowed. It's already running. So what you can do is you can read the data, make your own logic, and write back the data to this PLC or to any other PLC of your choice. You can do that. So this is the benefit of using this bridge app. You can process the data. So this was the example in which you can trigger the alarm back to S7-1500 PLC when the tank level is more than 70%. So this covers up our example 1. The last part of this example is we have to move the data from Delta PLC to Siemens PLC, and we have to convert the data. We have to scale the data. This makes it interesting. Now, if you notice in Delta PLC, the data is coming. If I show you here again, tag monitoring, you can go to tag monitoring and I drag my data of tank level and I monitor it. So this is coming in range from 0 to 100. And our tank range, if you notice the scale, is from 0 to 300. This is in centimeter. So what you can do is you can convert this range within the app, and then you can transfer this converted range to Siemens PLC. So you can transfer the data between the PLCs. How can you do that? There are several steps involved. All right, let's see the first step. The first step was we have to make sure our device is configured. We have our tags which are already configured. And we have to make a converter. So in converter, what do I need? I need to make sure the data is going in centimeter to this PLC, which means I have to multiply the data coming from Delta PLC by 3. So this makes it very easy. I will name this converter as scale level. Description you can give test or whatever you like, and type is my expression. And here I can put the expression. The data is variable by default X, has to be multiplied by 3, and click save. Very simple. So you have a scale level as a converter in which it will only convert the data. What is the data? We will define that, multiply by 3. And I will also make another converter, scale valve, because the valve range is 0 to 1000. I want to convert that to 0 to 100. Make it a test, expression, x divided by 10 and save. So we have two conversions. One is a multiplication of 3, one is a division of 10. Now if I go back to collector again, so we will take a new collector. So this time I will take a generic and JSON collector. Click on next and I will call it combined. And interval is 1 second, that's fine. Script type, I will take CSharp script. Write back function, I can make it true. Dynamic endpoints. Before coming back to business rule, I want to show you dynamic endpoints. Now we will take our endpoints as Delta PLC, tank level, all the valves, and tank level centimeter from Siemens PLC. Click OK. Now we have tags defined here. And now we want to convert the tank level from percentage to centimeter, for which we made a converter. So what I'm going to do is, this is my iTank level, and this is going to show me in percentage. I can add another tag, iTank level again, click OK. And here you can see that it says iTank level 1. It's a new tag. And here I will add a converter. I will add a converter scale level and click on OK. Now what will happen, here you can see that converter is added. I will click on save and let's test this collector. And you can see that now iTank level 1 is showing me the value with a multiplication of 3. Okay, let's check it out. I will start this. And now you can see that here, the iTank level from the Delta PLC is 31, 29, and this is multiplication of 3. This is iTank level 1. Okay, so you have two tags. One is showing the real percentage and one is showing in centimeter. This is what I want to show you. And this happens because we added a converter on this tag. Now you can see that here again, combine. Sorry, not here. I can show you edit. Here you can see that converter is added. Similarly, I can also scale for the fill valve and the drain valve. And this I can do that here. In the fill valve, I can add a converter of scale valve. And in the drain valve, I can also add a converter scale valve. Okay, and click on save. And let's try that again. And now you can see that the valve is showing in 100% open or 0% open. So we have three tags which are converted. This is what I was talking about, pre-processing the data before sending it further. The data is pre-processed, 0 to 100 in this for valve and 0 to 300 for the tank level. Okay, and if you see the message, you have all the data coming in JSON. Okay, this is the first part, how you can convert the data. Second part was we have to send the data to Siemens PLC in centimeter. All right, in the real time. To do that, what we can do is now we will write a business rule. So I will go to my business rule, and first I will define a variable. I will write variable tank level that is equivalent to endpoint dot, what is the endpoint I want to read from Delta PLC. Now I know that my scaled value is coming in iTank level 1. So I can use this one, iTank level 1, and I will make it to integer, semicolon. Now I want to write this value to my Siemens PLC. And in my Siemens PLC, my tag is iTank level centimeter. That's why I took centimeter. So business rule, I will write endpoint dot iTank tank level centimeter dot write. Now write is my function to write the values. What I want to write this variable here. Simple. Now click save. And you have to make sure when you're doing this in combined, your write back function is true, because this will allow you to write back to the controller. Let's test that. And now we monitor this. We can see there is some error. Let me see what is the error. iTank level. I think I have a mistake in my variable naming. This happens. So we have capital T for the tank. iTank level. here as well. That's okay. This should work. Let's check it out again. Now you can see that the tank level in Siemens PLC, you can see S7-1500, is written in centimeters. So let me open my Siemens PLC here. Thus you can see that. Now the next part of this example was how we can collect all the data and now push it to ctrlX core data layer. How we can do that and then visualize the data on the Node-RED, last part. So to do that, let's open that again, and very quickly I will go to my combined collector, click. First we need to add a connector. So ctrlX data layer is a connector. So I will collect the data. Now I have combined data collected. Now I need to connect that to my ctrlX data layer. In this case, I will add a connector. So I go to my plus, and here if you go down, you will see Rexroth, ctrlX data layer connector, click on next, and I can put the name, ctrlX data layer. Other options are by default, click on save. So my connector is defined. Now I will go back to my collector to make a test if this is working. I'll go to play, I will play the combined collector. And now I go to pause and I will connect my connector. So ctrlX data layer, this is just for testing. And data model I will not define now, we will come back to that as well. Go to play. And now when I do that, I have to make sure my pop-ups are working fine. And if you go to result, you will see ctrlX data layer if it is working or not. Now double tick means it's working fine. Now in ctrlX data layer, you will see a tag itank level, fill valve, drain valve, itank level centimeter, itank level 1, timestamps and ID. So all the tags which we collected, now we are sending to ctrlX data layer. If you want to control how many tags you want to send, this you can do that by going to combine and dynamic endpoint. So let's say I don't want to send fill valve or drain valve. I can select that and delete it. Click save and check this combined collector again. Pause it, click on ctrlX data layer, click on play. And if you go to result, now you can see that only the tags which I selected are being transferred to ctrlX data layer. So this I will revert back again. This is just for testing. I will read all the tags. Fill valve, drain valve, and fill valve, drain valve had my converter, scale valve, drain valve, scale valve, combined, pause, ctrlX data layer, and play. So now we have all the tags. To verify if this value is being written in ctrlX data layer, what we can do is we can open ctrlX core. So I will open a new tab, put it here, log in, and quickly go to settings, data layer, and here you will see a folder of DeviceBridge, which is here. Open this folder, and now you can see that the value is coming here. So now you know if your value is coming to your ctrlX data layer, you can push this value, you can use this value in your PLC engineering app, you can move this value to your HMI, or you can move it to the cloud. But in this example, we're going to show you how we can read this value quickly in the Node-RED in ctrlX data layer in ctrlX core. So I have Node-RED already running here. I'm just going to show you a small example. So data layer request, and here I know my data is already in the data layer. So I can read the data. Something went wrong. Let me see if everything is working fine. Data layer is not requesting. Okay, what I can do is, if you get this pop-up error, you can go to your data layer and you can copy this tag. So itank level, I will copy this one and paste here, click on done, deploy. And it's authenticated, so it's showing my itank level. If I just want to show you in my debug, deploy, and here I can give interval of 1 second. So the value is coming in my payload, and this value is coming in my percentage. And if I see my tank level, this is defined in percentage. I can connect this directly here. and my tank level is coming. Fill valve opening and close, so I can quickly do that for my valve. And we can see in the dashboard you have the data coming right away. So now fill valve is 100% open, so tank is being filled, and now draining started, so now tank is being drained. You can see the real live situation here. So that's how you can bridge the data from OT but not yet to IT. We are still in ctrlX core, but you have seen how you can show it in the dashboard and how you can play around with the data. So this was the example one in which we extract the data from our PLCs, pre-process the data using converters, and collect the data, connect that to a connector. And now, very important step, this was just the testing here, but you have to organize a route. So I'm going to do a routing here, and I go to plus. I will make my first route. So let's call it example 1. Description, I will write test. Now here I will collector. Which collector I'm going to use? I'm going to use combined. So this combined collector, I routed that to a connector, which was ctrlX data layer. And data model we don't have yet. I will show you what's the importance of that. Click add. And now you can see that this collector is combined to your data layer. And you can also add another connector if I define here, which I will show you in the next example, how you can have multiple connectors. So in this example, we have combined collector connected to connector, which is ctrlX data layer. Click on save. So your routine is defined. And the last step is we have to use a service container. So we use a container in which we will put our routines. So very simple, select one container, container 1, description test, and this is my routine which I just made. Drop it here, click on save. Now your service container is defined. Now we just have to publish that. I know a lot of steps, but this is how it works. So you publish this container, you go here, go to the publish this here, and it will show your wizard, no programming, no coding. It will check all your steps. You have to make sure everything is tick. Click on next. You have to select the service container as your instance. Click on next, and I will put a command example 1 test and publish. This will take a couple of seconds and it is completed. Close. And now if you monitor your service which you just published, here you can see that the status of your container which you just published. And from here you can start and stop, and here it's already running. So if I click on example 1, you can see that my data is being running, and I have to make sure what is happening here. Sometimes it takes a few seconds to start running this script. So if I go to my result, now it is starting to work. If I go to my result, the data is being written on the ctrlX data layer. These are the messages. It's like a log, how this process is going on, and you have a tag monitoring here. And finally, you can also see that this is being implemented in our dashboard. So this step you have to publish your service container. This completes our first example in which we have seen how to collect the data from the PLCs, how to bridge these two PLCs together, or these two PLCs to ctrlX core. In the next example, which is quite interesting, we're going to show how we can move this data from the PLC or different controllers to the IT world. So let's see that in the next example. Now let's proceed to example 2. In this example, it says we have to collect the data from two sources. One is my Siemens PLC, but in this case, now we're going to read via OPC UA. And one is Raspberry Pi, and we have to read via MQTT. In the same app, DeviceBridge. How we can do that? Now my PLC is already activated with OPC UA, and my Raspberry Pi is already configured with MQTT broker. All right. So let's see how we can add these two devices in DeviceBridge app in ctrlX core. So we go to device again, and you notice I deleted my old devices. So I will click on plus, and now I can see OPC, select OPC UA, click on next, and here you can put your device name. I will put S7-1500 and the IP address of my PLC. So I will put the IP address 153. Port address for OPC UA is 4840. An endpoint, you can click on browse and it will automatically find out with this IP address and this port address your final endpoint. So I'm going to use no security, so I will click on none. So rest, I don't have to do anything. 1 second is fine for me, and click on save. So your OPC UA driver has been selected for S7-1500 PLC. Now I have to add some tags in it. So click on this device here, click on the plus, select the tag type. Here you can see OPC UA write tag. I'm going to use a write tag because maybe I show you how you can also write back the value, but it's not necessary. If you don't want to write back the value, you can also use a read tag. But in this example, I don't think we are going to write any value, so I will just take a read tag, just depending on what you want to do. Here I have to put a tag name, and I will put a tag name as iTank level again. And comes the tag. Now here I have to make sure my tag address is correct. So my tag address is NS3, and this is my string tag, and I can select my tag. And if you know, my tag is stored in the data. So I have my database called data, and in that I have a structure called data, and then iTank level as integer. So I will put data, again data, and iTank level, this one. Let's check it again if it's correct with my uppercase. Sounds great, and click on save. Now you have a tag defined here. Let's check that again. This tag is defined, and if I want to browse, let me see if I can read the value. Oh, you can also directly read it from here. Anyways, I've defined my tag. Now let's click on adding another tag. Click on save, and let's see if we can monitor these tags. Go to monitoring, and here you can see that the value is coming 0 and this is coming true. Let's see if it's fine. Looks great. I can add 56 and make it false. 56 and false, and here we have 56 and going back to 0. Okay, let me check that again if any routine is running. Oh, my container is running, so let me stop that. This should be okay. Now if we check 56, now this value is being read in my device. If I go here, now if I want to monitor the device, you can see that the value is 56 and false. So if I see here, this is 56. If I make it true and change that to 33, you can see that the value changes here. All right. So a device is being read, the device tags are being read in our ctrlX core using DeviceBridge app. Next is we have to add Raspberry Pi via MQTT. In this case, I go to device again, click on new, and here let's find where you can find MQTT in protocols, MQTT, click on next. Device name, I can put Raspberry Pi. The IP address of Raspberry Pi, let me check from my source, it's 154. Port address is 1883, that's correct. Timeout, I have no username, no password, no protocols, click on save. And now inside Raspberry Pi, I can add a tag. So select tag type, it's MQTT tag, click on next. And now I have to see which topics I have defined here. So if I see my Raspberry Pi code, I want to read temperature and humidity. These are the two topics which I've defined in the MQTT broker. So I'm gonna connect as a client to the broker. So let's call it humidity, and the topic name is same, and the data type, it's coming as an integer. Click on save, and another tag which I want to read is temperature. So very quickly I will take temperature, topic name is temperature, reading as integer. So I have two tags coming from the MQTT. Let's see if I can read that. Perfect. So I have a humidity 14, temperature 37. And this is coming from my Raspberry Pi. You can see that here. Humidity 14, temperature 37, and also brightness, which is 4. It's a bit dark in my room. That's okay. We just want to read two variables. So you can see it's changing based on my room parameters. And this temperature is not my room temperature. This is the, the IC temperature of the, in this, I have a sensor connected on Raspberry Pi. and the sensor is inside the Raspberry Pi, so it's a bit hot. So don't consider it my room temperature, I'm not burning. All right, so Raspberry Pi is connected, PLC is connected, and now the next task is to send the data to the cloud. In this case, I'm using Cubitro Cloud. Okay, so we need to add a connector now because we are sending the data to the cloud. Let's go to the connector and click on add. And here, let's see what do we have. Now this cloud MQTT Cubitro is also MQTT protocol. So in this case, I will also add an MQTT as my protocol. All right, this I will find where I will find this cloud MQTT connector. Click on next. And now I will add a name here. MQTT cloud. It's Cubitro is the cloud service. And the IP and the host name, I will read it from my, well, I wrote it somewhere. It will be broker.cubitro.com. Port address is the same. The topic type is single, and the topic name, which is defined on my cloud, is this one. This is also my username, and then I need my token because I'm connecting to the cloud. So I need ID and password. This is more secure. That's it. So I have a topic to which I'm going to send the data, and I have username and I have my password. Click save. So my connector is defined. All right. Let's come back to collector again. Now, first I have to define a collector. So I have just device here. I forgot the collector part before. Let's add a collector. And now in this case, I will take a JSON collector, a simple JSON collector. I will write MQTT cloud. Okay, just maybe example 2. And script type, I don't need to pre-process the data. And here I'm going to select my information. So Siemens PLC is giving me tank level, Raspberry Pi, humidity, and temperature. Click OK. So I have 4 tags collected by my collector. Now comes the important part. We have to send this data to the cloud, and cloud has a specific format to receive the data. That's why we need a data modeling. In data modeling, we define how we read the data, how we format the data and send it to the cloud. So just a small example, I want to show you how I'm going to format this data. In case of my Cubitro MQTT cloud. So in this case, I have predefined my data. So in the data model, I will go to plus. So this you define in the data model. And here I'm going to add a basic data model. Click on next, and I will write here MQTT cloud Cubitro, just the name of my data model. Test description, data model type is simple. Model is JSON, and I will just paste it here. Now what is coming here? I have a key named timestamp, tank level in centimeter, alarm status, humidity, and temperature. And here what you see, this is the tags which I'm reading in my collector. Let's verify that if this is correct, because this example I did before. I will take a collector, edit, go to dynamic endpoints, and here you can see the tags. I'll make a small screenshot. This is my screenshot. Now I will go to my data model, cancel data model, verify if I took the correct tags. So I took I tank level, which is correct. This one, X alarm is correct, humidity and temperature is correct, and timestamp is by default. Okay, everything looks great. Click on save. And here you can also mention the key. For example, I can mention Siemens PLC, tank level in centimeter, alarm status. I can write Raspberry Pi, humidity coming from Raspberry Pi, just for the reference, Raspberry Pi temperature. So this information you can define, and here are just the variables. So you have to make sure the variables are correct. Click on save. Now again, I will just want to check this. I will go to my collector, click on play. First, I will see if my tags are coming correctly. Coming, no problem, no errors. Messages, I can see my JSON being created here. Now, what I can do is I can go to pause, but notice here, by default, the JSON is named like this. Okay, if you want to modify that, click on pause, select your connector, cloud, select your data model. This is the data model which I collected. Now click on play. and let's see what happens. So it will take a couple of seconds to try to connect to the cloud. So we will wait a few seconds to see the information. So tag read is correct. Now it says successfully pushed to the cloud. You can see double tick. And now here you can see that your key value is coming like this. Alarm status, Raspberry Pi humidity, temperature, timestamps. Now if I want to show you my cloud, you can see that it's here. And here I have already defined a dashboard, but before that I can show you where I have used these values. So ctrlX automation, this is my device, and if I refresh that, these are the values which are coming. Raspberry Pi humidity, Raspberry Pi temperature, Siemens tank level, timestamp, and alarm status. So if I change the alarm status to false, and let's change this to 67, and we should be able to see the changes here. I have to refresh it manually. Now it's false, and this value is 67. And if I show you my dashboard, you can see that these values are updated here. Okay, so this is just to show you how you can move the data to the cloud. This we have done using MQTT. Okay, we have sent the data from Raspberry Pi, from Siemens PLC, from different protocols, define the data model, change some key values, and send it to the cloud. Super interesting. The same example we will do, but in this case, now we will send to MongoDB, also running on the cloud, for a fraction of seconds. All right, in this case, we have to add a new connector. So we'll go to plus icon again, and here we have to find database and Mongo connector. Looks great. So in this case, now we have several parameters. So let's name it as MongoDB Cloud as the name. Description is okay. Connection string. Now we have to add a string. Now what happens when you make an account in MongoDB on the cloud? You have several options to connect to this cloud. If you click on this connect button here, you can select the second option, connect to your application, and you will see a driver chash.net. And here you will find a string here. So just copy this string, go back to your ctrlX core and paste it here. Now here you will notice you have a username and password. This you can find in your account. Go to your database access, create a new database user, and I make it as an admin. Now here I know my username is ctrlX and my password is also ctrlX, so I will just put that here, my username and password. So this is my string which I need for connection. Now it asks for your database and collection. What you can do that, you can go to your database again, and let's create a new database. In this case, it will ask you which database you want. I will create a shared one, and you can define the area. I will put Frankfurt closest to me and create a cluster. The project had already free cluster. All right, so I think my project already has a cluster. Let's see that here. I cannot create new because I'm using a free account. So if you see browse collection, I have a database Bosch DB and a cluster also by the same name. And I have some values coming here. So I would say I can maybe delete this, or I can make a new collection in this one. So let's call it as bosch.cl and create. So I have my database bosch.db and I have two collections in that. I will use this collection to make it simpler. So let's go back to my ctrlX core and database name. I will just copy that very quickly. bosch.db and my collection was bosch.cl. Simple, click on save. So my connector has been added. Now I want to show you how you can move the data to this connector with a different data model. We have seen the data model of our MQTT cloud in Cubitro, and I can add another data model, a basic data model. In this case, let's name it as MongoDB Cloud Test. Simple. And now I have already created a data model for testing. I will show you here. So here I have an extra parameter called system parameter with extra keys like device, tank level in centimeter, alarm status. This is different than the model which we defined for the cloud, for Cubitro. Here we have different model. This is just to show you how you can play around with the data and send it to your IT service or IT part with a different data model because of the different requirement of your IT. So Bosch Bridge app will help you to do that. Inside it, you can define your data model, click on save. Now this is defined here, MongoDB Cloud. Now I will go back to my collector and I check this with a new data model and new cloud settings. So I'll go to my MongoDB Cloud and MongoDB Cloud here, and here before I go back here I want to change the time. So instead of sending it every 1 second, I will put every 5 seconds so that it's not sending the data, a lot of data. So now again I will go, okay, sorry, not here, plus icon, selecting my MongoDB, a different model, click on play. This will take a couple of seconds to make the connection and we're gonna see the result very soon. So now here you can see it's 1 tick. So if you have 2 ticks, it means it's connected. So we wait for the connection. Sometimes it takes some while to connect to the MongoDB if my connection settings are correct. All right, I noticed that there was a problem in the username. I have an extra white space. You have to delete that. So you have to make sure you are doing it correctly. So once I fix it, now let's check that again. I go to this play icon, pause, select MongoDB, data model MongoDB, and play. And now the data should be going to the cloud. So let's check that. Now you can see that here you have a double tick. And if you go to your MongoDB and refresh, you will see in your collection you have the data coming. Your Siemens parameters and Raspberry Pi parameters. Let's check the last parameters. Here you have temperature and humidity. So your data is being moved to the cloud from Bosch Bridge app. All right, this was what I wanted to show you, how you can move the data to the Mongo cloud. Now we make a new service routine. So I go to my routine, routing, not routine. And here I can type example 2, description test, collector, I'm going to use example 2. And now for the connector, I will use both. I will use MQTT Cloud with conveter with its unique data model. And I will add another one. Here instead of this MQTT Cloud, I will select MongoDB. And the data model is, oops, not here. Let me do that again. And here it's MongoDB. So you have unique connector, it's unique data model for MQTT Cloud and MongoDB, and your data is being collected by one collector from 2 devices. Let's save it. And the same steps after making a routing, we have to make a service container. I will name it as example 2. Test it, drop my root here, click save, and I have to just publish that. So let's publish it, and it will tell you if all the steps are correct. Looks great. Next, and I'm going to put here example 2 test and publish. So once my service container is published, I have to check my service monitoring, and it will take a couple of seconds. It's already running. So if you have this message, just wait a few seconds. It will start running every moment, any moment, and you will see the result in results. Here you go. Seems like working. And let's have a look. Tag monitoring result. Now you have MongoDB, MQTT double click, and MongoDB may take some more seconds. And if you want to see in the meantime messages, you can see that data is pushed to cloud conveter successfully, and to the MongoDB it should also go. Now you can see it's going to the MongoDB, it's going to the MQTT cloud all together. And this you can see it's reflecting in your parameters here. So I can change the tank level, let's say 89. This I can give it false because I'm not using it. Here it's going every 5 seconds. So this was 67 and this should increase to 89. You can see that it's increased now. And if I see my collection now, I will refresh the data, and the data is coming in the last collection. So let's see that here. Now you can see that the value is changing. So the value is being read from the devices and being sent to the cloud in MongoDB and conveter cloud. It could be any cloud of your choice. All you have to need to know is the parameters you need to put inside your connector. So the idea of this video is to tell you how easy it is to collect the data from different sources and process this data, which is required by the IT world, in a different format. This you can do using converter or using data model. All right, I hope you like this lesson. It's a big video, I know, but I hope you enjoy this and you can use some part of this video in your project. And if you face any doubts, feel free to comment on my video. Thank you for watching, and please subscribe for more videos. In my next video, I'm going to talk about how I can use ctrlX core to talk with IO-Link master. All right, we will see that in the next video. Until then, enjoy, have fun, stay healthy. Bye-bye.